In this lecture, we're going to talk about the additions of vector of rectangular components. We know that in resolution, we first made a vector or suppose a vector for from the origin. Just suppose the terminal of this vector is B. We're going to resolute this vector. So we're going to make a line or the resultant along the y-axis to the x-axis. This is the resolution of the two vectors. Ax is equal to cos theta because it is along the x-axis, and by is equal to sin theta because it is along the y-axis. Then when we made another vector from the terminal of the first vector, just suppose this vector from the origin to this point, terminal point, it becomes B, and another vector from the terminal point of the B reaches the point C. Now the resultant vector of these vectors should be R, or we can say that we can resolute these two. This is resoluted before. Now let's resolute this another vector. So we're going to make the line along the x-axis to make an origin, as a vector is covering the distance, and we're going to make a resultant vector joining the terminal of vector C. So we can say that this is A2x because it is the component of another x, and this is the B2y because it shows us the B, the x-axis. Now we know that the magnitude of the A is equal to A and the magnitude of the B is equal to B. Now what I have done, first suppose a vector O B resoluted along the x-axis. Just name the resolution along the x-axis by and resolution along the x-axis as the ax. Draw another vector from the terminal point. Take the resultant vector. The magnitude of the A, this vector, is equal to the A, and the magnitude of the B is equal to the B. Then resolute another vector by drawing a line that resoluted from the x-axis, and then join the terminal of one to the terminal of the another and name it as B2y. And we know that the x-axis we named it A2x. So which is this line is parallel to this, so we can say this line A2x also. So we had just made a singular and parallel or perpendicular form of an vectors to make it a single axis, as we had made it here also. So let's find out the final step of that. What we had made, resultant vector along the x-axis and the y-axis. The resultant should be taken as the ax, a1x and a2x. Now we know that the formula to find the magnitude is hypotenuse squared by the base squared by the perpendicular squared. So for removing the square, we're gonna take under root of both sides. This square will cancel the under root, while this components will be in the under root. We know that the components of the ax is a1x cos theta, a1x cos theta because it is in x-axis, and a2 cos theta because it is also in x-axis, plus we have done the x-axis. Now y-axis, b1 sin theta because it is in y-axis, and b2 sin theta because it is also in y-axis, and this is magnitude of the A and B. And this is all about today's lecture.